Okay, now we've got some questions on slope here. So this is part 2 of lesson 7.3. 7.3 on characteristics of linear relations. So we've got a grid that has been put on top of the sketch of somebody working on a roof, and we're going to estimate the pitch or the slope of the slope of the roof to the right of the worker's head. Pitch is a word that's used for roofs. Okay, so you can't. It's not a great drawing, honestly, but they tell me that this point right here is on the grid. Oh, come on. Doesn't like circles. So this one right here. Oh no, it doesn't like anything. Let's try that again. Okay, so that point right there and this point right here is supposed to be right on the grid. So that gives us a run of 1, 2, and a rise of 2 and a run of 1, 2, 3, 4, 5, 6, 7. So that gives us a slope of 2 over 7. Okay. Could this grid be used to estimate the pitch of the roof the worker's standing on? This one here. No, it's not. It's not in the plane of the grid. Like, if you stood over here instead and you were looking that way, you'd have a very different view. So it's the wrong perspective, or not in plane of the grid. Okay, the 3D thing doesn't work. Okay. All right, draw a segment on this grid which passes through the point -4, 2. So let's find the point -4, 2. So we start at 0, 1, 2, 3, 4, and up to -4, 2. So there's our point, -4, 2. And then we're going to use a slope of -2 over 3. So it's really important to remember that -2 over 3 equals 2 over -3, where this is the rise and this is the run. So from my point, I can do, if I use the first one here on the left, I'm going to have a rise of -2. So I go down 2 and a run of 3, 1, 2, 3. That puts a point here. And then I can do it again, down 2 and a run of 3. Down 2, run of 1, 2, 3, down 2, 1, 2, 3. Now, those of you that were in my class last year, you remember that I had you doing this to draw your graphs, right? I didn't call it slope, but I had you doing this because you want to draw your lines from points that are as far apart as possible. That's why you did that. But to go backwards, we move the negative sign so that our rise is 2 from our point, our rise is 2, and our run is -3. 1, 2, 3. We're going backwards this time. Rise of 2, run is -3. But those, you can see those are all on the same line. And then we draw a line through them very carefully with our ruler. And this is a line, so well, that's a big fat line. That's not what I want. How do I change that? Pen properties. Let's go down here and make it that color. Okay, is that better? It's better. It's still pretty big. It's good enough for this though. Okay, so I'm going to make it go through there. Okay, no, you should do a smaller line than that. I'm sorry. I will. It's not worth it for me to do it here, but I'll make sure it's good on my paper copy. Okay, because it covered up all my lines. Okay, and then write the coordinates of. No, I got to fix that. Sorry. Okay, let's do that line again. Draw line. Okay, so from here, and then I can grab it and I'm going to put it down, making sure it's going through all my lattice points like that. There we go. That's pretty good. Okay, that's better. So other points, I've got -10 and 1, 2, 3, 4, 5, 6. I've got -5, 6, 7, -7 and 1, 2, 3, 4. Got -4 and 2. I've got -1 and 0. I've got 2 and -2 and 5 and -4 and 8 and negative 6. So hopefully you can see. I mean, I know I listed all of them, but in case you did it and wanted to make sure yours was right, there you go. Okay, a line segment has a slope of negative 5 over 7 and a rise of 12. Calculate the run as an exact value. This is a proportions question. Do you remember teachers telling you that proportions are super important? They use them all the time. Okay, rise over run. So our slope is negative 5 over 7. I'm going to float the negative up. Doesn't matter. They get the same thing. And so if my rise is negative 5 and my run is 7, I've got another place where I could measure it, like, because I can measure it anywhere and it's the same thing. And my rise is 12, and I'm looking for the run that goes with a rise of 12. I'm going to cross multiply and divide to solve this. So R equals 7 times 12 divided by negative 5. So R equals 84 over negative 5, but then I would write that as R equals negative 84 over positive 5, because we just usually write the negative on top. That seems weird, doesn't it? But you know how we can check if they're the same? We can use our calculator. So if I take my calculator and I go negative 5 divided by 7, I get negative 5 divided by 7. I get negative 0.7142857. And then if I do 12 divided by negative 84 over 5, and I do that calculation, 12 divided by bracket, negative 84 divided by 5, bracket, equals, hey, look at that, it's the same number, negative 0.7142857. So those are the same, okay? So there we go. Go ahead and do the rest of the questions in this lesson. Bye.